All right, for this project, we're going to go through the results of the water chemistry lab because I did these results, and again, I apologize for not getting them out there appropriately to you. We just sort of threw it out there and didn't really give you enough information. So we're going to do that now. And whenever we look through some of these, I'm going to talk about some of them, and we'll take a look as we go through. So this is just going to summarize the results that we had, and I'll walk through them with you. So when we look here at the water chemistry, what we're really looking at overall was the water quality and kind of understanding how what water quality means. So, we went out and we kind of did this aquatic ecology site visit, and the quality of the stream is kind of a reflection of both its chemical and physical characteristics. The physical characteristics were what you observed when we were out there physically in the stream. The chemical characteristics are kind of what we sampled here, and I'm going to go through those. For the physical characteristics, those are kind of some of the things you observed. At the end, I'll go through some of the things I remember that I observed while we were out there, and both the biotic and abiotic factors that go along with these things. So, some things to keep in mind that with this stream is, we look at a lot of different chemical characteristics. The presence of a little bit of a chemical for even a short period of time can be harmful to a stream. So we will look at different, insects, macroinvertebrates, microinvertebrates, invertebrates, all tell you a lot about a stream. If there aren't a lot of insects and macroinvertebrates around a stream, it's probably not a very healthy stream. So, we went through and we did some observations of some of those out in person. And then what we did is I went through and ran all the chemical tests. So I'm going to go through what our results were for our chlorine and hardness, for our nitrogen, for our pH, and for our different things that we found here. So it'll just kind of give you an idea. And I'll talk about each one of them, what's high, what's low, and what different things should be to kind of help you out a little bit. All right. So when we look at chlorine and hardness here, as we look at these, we're looking at these two rows right here on the end here. They basically showed that they have 0 total chlorine and 0 on free chlorine. That's good. When we look at hardness, we notice that the calcium carbonate here is pretty high, 25 grams per gallon is pretty high, or 425 parts per million. When we look at those, that's actually pretty high. But this is a result of, if you look at what the stream banks were, if you remember seeing a lot of rocks, a lot of limestone around there, that is going to make the hardness as the calcium leaches out into the water. That's going to make it harder. So that's just one of those things that's going to happen with streams that are limestone banked and things like that, and kind of runs through a lot of those areas. And if you remember, we've seen quite a bit of that in person. So no chlorine, but it is pretty hard water, is what we say. And that hard is because of this calcium carbonate that's in here. So just kind of something to think about. So the alkalinity and pH are what we're going to look at next. The alkalinity, the pH here, alkalinity is a buffering capacity of the stream. So this is the total alkalinity here whenever we're looking at this. So the higher the alkalinity, this is how much acids can be removed from the stream. So as we look here, we have a pretty high capacity, about 180 to 240. And it measures the amount of compounds such as carbonates, bicarbonates, which that makes sense because our hardness was pretty high. So that alkalinity was probably, it was a little more that availability, those calcium carbonates and things, and bicarbonates, they're natural buffers that can remove excess acidities and hydrogen ions from the water. Those are good things. The pH then we look at next. Our pH didn't roll over much, but it's about a 7.8 that we have here. And so our pH being about 7.8 is pretty good. Neutral being 7. We expect it to be a little on the higher side with some of those higher alkalinities in there to kind of neutralize some of those acids and maybe even make it a little bit basic. Then when we look at dissolved oxygen, when we look at the biological oxygen demand is the amount of oxygen that gets consumed by bacteria. So when we look at dissolved oxygen is kind of, there's things that go into this. The biological oxygen demand is how much oxygen is consumed by bacteria. The chemical oxygen demand is the measure of oxygen that's being taken up by different and being bound up by different chemicals. So a lot of times ammonias and other things like that in the water will make the oxygen not available to the organisms, and that's bad. So what we look at is this number here is the total amount of dissolved oxygen, and that's this number. The number down here is actually the temperature of the water, and they are correlated. So the amount of dissolved oxygen is expressed as a concentration. This concentration is 7.1 milligrams per liter. Okay, could also be parts per million, but we did not do that. This is milligrams per liter. And a 7.1 is really kind of right about where we need it. We would probably even like it to be a little more with this, but this is kind of what we get. Now, there is a direct correlation as oxygen increases. There's more dissolved oxygen in colder water. The warmer the water is, the more the oxygen will actually volatilize out. So also, the higher oxygen concentrations will show up where there's more water flow. The presence of aquatic plants affects dissolved oxygen. Green plants release oxygen in the water during this, so that can cause it to fluctuate. As the plants are doing photosynthesis, they might actually have more oxygen right after photosynthesis than at night. Altitude would also affect it. We don't have that around here in this sample, but if we were at a higher elevation, a higher altitude, we would have more dissolved oxygen in those streams. So just some things to keep in mind. This number of 7.1 milligrams per liter is about average. In the 23.8 degrees Celsius, because we had a shallower sample, that makes sense for that sample too. So this indicates it's a fairly healthy stream still. Now, when we look at nitrates, this is something that, whenever we think about the different nitrates and things like that that are going to be in it, nitrogen in the water, nitrogen is important to all life, but what we want to be careful of are nitrites, nitrates, and because what they get converted to is ammonia. And so we measured the nitrates here. Nitrates occur in surface water, and they can be found in concentrations up to 30 milligrams per liter. Ours is pretty low at 4.6, but what happens is these nitrates get converted to nitrites, which get converted to ammonia, which get converted to organic nitrogen, which becomes very unstable and will volatilize and can be problems. Nitrates are not harmful, but when they get converted to nitrites, they're very harmful to aquatic life. And organic nitrogen is very, very harmful. It could be very harmful to water and things like that. So basically, what happens is as the nitrates get converted to nitrites and ammonia, the plants will take this up. The more plants that grow can cause more and more problems in a stream with eutrophication and different things like that. So you want to make sure you keep those in check. This indicates our stream is fairly healthy. We also have our phosphorus here. I'm sorry, the picture's a little bit sideways. But with our phosphorus, organic phosphates that we have here is what we measured. and this is bound up in plant and animal tissue. So this is as plants decay and animal waste and animal tissues decay, we end up getting more phosphorus in here, and it can get suspended in there. And whenever this phosphorus can become reactive or orthophosphates, the phosphorus can provide you some measures in here. This is pretty low. 1.86 is fairly low on the phosphorus scale. We would look for a range on the phosphorus, anywhere from 2.0 to 3.6 on this scale. So we're pretty low on our phosphorus. So we're not going to see any problems with phosphorus in this stream. It all seems pretty healthy with that. So some of the conclusions, based on your observations, is this a healthy stream? My observation is yes, it's a healthy stream. We've seen quite a few things. I know several of you found some different organisms that were around. I can remember seeing a couple of dragonflies. I know I seen some different organisms and different things like that in the stream. I seen a few water beetles. We've seen several of those around. So we've seen several of those, and we've seen several flies, water flies, springtails, and a lot of stuff like that growing on the streams. So that makes it all fairly healthy. So hopefully this will help you guys complete your exam.